All of these projects that are saying blockchain is the answer or DAG is the answer are being short-sighted. I think that there is a pitch, there's a use case for using these technologies in tandem with one another. What is up, Hash Nation? Today is Tuesday, and that means it's Token Talk Tuesday. Today we are talking about Nano, formerly known as Raiblocks, and that is a cryptocurrency project that is taking a really unique approach to achieving fast and nearly free transactions at scale. So how are they doing this? Well, let's hash it out. Now, for those of you who tuned in to my Token Talk Tuesday last time around about Digibyte, you know that Digibyte has done quite a lot of work to create a really unique proof-of-work blockchain ecosystem based on a UTXO model that is capable of achieving fast transactions and nearly free transactions at scale. Now, Nano, the platform that is the target or the main star of today's Token Talk Tuesday, is another platform that's doing just that. And Nano is really targeted at e-commerce and other platforms that require large volumes of transactions that are pretty much free and really quick. Nano was created by Colin LeMahieu, a developer and entrepreneur with a background from Dell, Qualcomm, and other big tech companies of the like. The project itself was launched in 2015 under the name Raiblocks, and some of you may have heard of Raiblocks during the 2016-2017 run-up to the crazy prices that there were at the end of 2017. Later in 2018, Raiblocks was rebranded to Nano, which is the name that it goes by today. And according to the white paper, Raiblocks, or Nano as it's called today, was intended to be a cryptocurrency that is by design super fast, scalable, with zero fees. So how is Nano designed to meet this requirement? Because as you know, scalability is a big question mark today in the cryptocurrency world. Well, here's where Nano really differentiates itself from a lot of the other platforms out there today. It uses directed acyclic graph technology, or DAG technology. And again, some of you may have heard of DAGs in this market today. Some people say, oh, DAGs are the blockchain killer, or blockchains are better than DAGs. Really, I think that these are complementary technologies, different implementations of a similar concept. And so I don't think one is definitely better than the other wholesale. I think there are really good features for both. Now, essentially, Nano uses directed acyclic graph technology as a sort of mesh or web of all sorts of different data. And this data is fed by individual user-managed blockchains. And yes, you heard that right. Nano at its core relies on something called the block lattice. And the block lattice is essentially a series of interconnected user-managed blockchains. So each user has their own blockchain to keep track of their transactions with other people. And in between that, the main layer that keeps track of the state of the network is that directed acyclic graph technology that really forms that lattice of blockchains, aka the block lattice. Now, as you may have inferred from the description just now, there are two distinct pieces to the block lattice. But first of all, let's talk about the blockchain side of things, those user-managed blockchains. First of all, what you need to know is that each user account, or each user, which is really defined by a key pair, has its own account chain, or its own blockchain that keeps a record of different transactions and blocks that have occurred for that particular user. And of course, only the owner of that blockchain or the owner of those keys can make updates to and send transactions from and on their own account chain. And that being said, that means that these individuals can start the process of making a transaction without having to rely on others, without having to rely on the entire blockchain network itself like you see in other blockchains out there today, Ethereum, Bitcoin, etc. However, you may be thinking, well, that's all well and good. If everyone has their own blockchain, well, how do they transact with one another? How do you keep one central source of truth or one version of the state of the network? And that is where the lattice part comes in. That's where the directed acyclic graph comes in to help connect all these different account chains. Again, this lattice or this directed acyclic graph that connects all these account chains is really the connective tissue that makes this system work. And one of the reasons why it works so well and so fast is because you're no longer relying on consensus on one main blockchain, you can have transactions occurring concurrently all across the network at any given time. That's one of the benefits of the directed acyclic graph, or DAG technology. Now, in this block lattice environment, to create a valid transaction, there has to be an originating or sending transaction block, and there also has to be a receiving transaction block that balance against each other. You'll remember in my last video, I'll link that above, about DigiByte, in a UTXO model and in most blockchains overall, the whole idea is that the inputs to a transaction have to equal the outputs so that no coins are created out of thin air and none are destroyed. And that is the same concept here and pretty much all payment methods. If you want to create a transaction, you have to have a sender and you have to have a receiver, and those inputs and outputs have to balance against each other. So again, in the event that a sender creates a block on their own account chain saying, I want to send X amount of Nano over to this person, and that block lattice technology starts to look for that receiving block for that exact amount of value. And until that receiver signs their own transaction or their own block to their own account chain saying, yes, I've received these funds, yes, this is a transaction that I approve of, it isn't official, it isn't a verified, validated transaction. And just in case you're wondering, how do they match the sender's block, the sender's transaction, to the receiver's block, the receiver's transaction? And that's done in a clever way by hashing. So the hash of the sender's block is stored or referenced in the receiver's block, so the protocol knows which sender's block corresponds to which receiver's block. You're probably sitting there thinking now, well, this gets really inefficient really fast because you have to propagate all these blocks across the entire network for every account chain across the entire network. And you would be right. But Nano uses something called state to their advantage in this way to limit the amount of propagation required to validate transactions. For example, if I wanted to send 50 Nano over to my friend, the way that that transaction would be created is I would take my new sender block that's required to create this transaction to send Nano over to my friend, and it would subtract from the balance of my previous block, the previous verified block. So let's just say I had 100 Nano tokens as of the last block on my account chain, and that has been verified by the protocol. Now I want to send 50. So what happens is that once the transaction that I create with my sender block, the new one that I'm sending to my friend, it's gonna see, okay, yep, you had 100 then, now you've sent 50, this transaction's verified. Your new balance as of this block is 50 remaining. And so you can see that at that point, that is the state of my account. That is the state of my balance. And to really track to that state, you only need the past few blocks to see a little bit of a history of where your account is. Obviously, you have to trust the protocol, you have to trust the network to believe in that state, to believe that what you're seeing is the correct thing. But it's a clever way of reducing the amount of propagation that has to be done for different blocks on the overall block lattice ecosystem. Now, that means that to maintain state and to make sure that everything is in order, the protocol only really needs to see and propagate the last 3 or so blocks for each account chain. And that's a lot easier to keep track of, and it's a lot less storage space required and a lot less computational resources required to do that than it would to verify the entire blockchain every time and keep an entire account record or an entire full blockchain worth of information every single time you want to verify a transaction. Now, you can think of state as a snapshot at a given point in time for every user's balance. And obviously the idea of state is that everyone should understand the state of their account and the state of other accounts. And the protocol should always understand a universal agreement upon the state of everyone's user account. So whether or not you have an unsettled transaction out there pending a receiving block, or you have verified transactions and a guaranteed balance in your account, the protocol needs to know that, and that is what state is overall. This whole concept means that transactions can happen asynchronously, and that means that different transactions can happen concurrently without having to wait for the last one to be verified. Now, this doesn't mean, however, that you can create a bunch of transactions that are more than your overall balance and then someone can create receiving blocks and that's going to work out fine. There are still validation rules that make sure that inputs equal the outputs, so on and so forth. but it means that throughout the network, you're not waiting for one block to be mined and then the next and then the next. All of these different state transactions and snapshots are occurring in real time constantly over and over and over again. And that allows the network to verify transactions at a much more rapid pace because you're not waiting for individual blocks to be chained onto one another in a certain cadence of time. And furthermore, keeping with the theme of making this protocol lightweight, making it faster, making it easier for the protocol to scale, the Nano block lattice structure uses a messaging system called UDP. And UDP stands for User Datagram Protocol. The packets of data within the UDP protocol are really great for low latency applications, meaning you want very little lag time between the send and receive operations within the sending of data. And beyond that, it is a really low bandwidth system, meaning it doesn't require a really large amount of data and compute resources to move that information from point A to point B. That being said, UDP and the usage of UDP in this context keeps the overall storage capacity and storage requirements relatively low, and it also keeps the bandwidth requirement relatively low for even large volumes of transactions. Now you contrast that with TCP, which is part of the TCP/IP platform or network solutions that we have that run the internet today. TCP is a much heavier and more bloated system, but it does have a lot of features related to error handling and combining packets that may have been lost or replacing packets that have been lost along the way. UDP does not have this capability built in at its bare bones. UDP is very much a bare bones solution to data packet transfer. And that being said, error handling is not one of its strong suits. So if packets are lost, there isn't inherently a mechanism for fixing that. So I was definitely curious about how Nano has gone about solving this problem in this context. Granted, the transactions that they're sending are so small in size that I doubt that large volumes of packets have to be sent for each transaction, so this problem may have been mitigated there. But I'd be curious to learn more about that whole implementation of UDP and how they've mitigated some of the risks that are intrinsic in using UDP as a packet transfer protocol. Now, furthermore, again, keeping with this theme of lightweight, low storage, low compute resource intensity, Nano does not use a heavy-duty consensus mechanism. Some would say that there isn't really consensus in any true form or fashion here. And I guess that depends on what your overall definition of consensus is. The network does reach consensus of sorts on the state of the network. However, it is not an economically driven process. It does not have proof of work or necessarily proof of stake in the network overall to reach consensus on a day-to-day basis. We'll talk about how proof of stake is used as a validation mechanism later, but more on that in a second. Because of the fact that Nano does not use proof of work and the consensus process, if you can call it that, is so lightweight, pretty much anyone can run a node on most devices. Even the weakest, least capable pieces of hardware can theoretically run a node. And of course, that's good for adoption. That's good for creating transaction volume on the blockchain network or on the block lattice, because the more nodes that are available, the easier it is for people to create and actively participate in the network, execute transactions, do things on the network. That's what you want. That helps drive more adoption and more volume. Now, like I alluded to just a few seconds ago, the Nano network does use delegated proof of stake as a sort of supplementary consensus mechanism when there's a conflict. Now, again, like I said, there is no true consensus mechanism in this block lattice infrastructure, and the way that Nano works does not rely on traditional consensus. And I know a lot of people may criticize that, and I definitely understand why. However, let's discuss how proof of stake is used in the event that there is a disagreement about something that's going on the overall block lattice. In the event that there are malicious blocks added to the network or transactions added to the network, there's obviously going to be a disagreement on how to handle that overall process. Now, to handle that, delegated proof of stake is brought into the picture. So there are a handful of nodes, and I think right now that number is around 5,000 different nodes that have the right to vote for which blocks and which transactions are actually going to hold true on this overall block lattice. So let's take an example. Let's say an account chain has created two blocks that are conflicting with one another, and the whole entire network needs to figure out how to handle this different fork that there is in this account chain. So what happens is that all of the eligible proof of stake nodes, all the delegates that are eligible, those are the ones that have the overall most stake in Nano cryptocurrency on the ecosystem. They're called upon to use their stake, their overall amount of cryptocurrency that they hold, as votes for which block is going to be the one that rings true, the one that stays on the network and continues forward. There's a rule here that 50% or more votes start going to a particular block. That means that most of the other delegates are supposed to, I say supposed to, they're supposed to move their votes over to that block, make that the official block, and continue on. That's to prevent the network from stalling out because you can't reach majority. Now, of course, that does present a problem because what if that is the malicious block? The reality is that if you have a conflicting transaction, one or the other has to be true to satisfy the input-output rule. And I think the belief is that statistically, by probability, that is the block that's going to win the most votes. Because people in this proof of stake environment, the delegates that own the most tokens on this network or own the most coins, they're going to want to make sure the network runs smoothly, and they are not going to choose a malicious block as the winner. Now, I can already hear in the comments people saying, well, Nano actually does use proof of work, and that is true, but it's not used for consensus. It's not used in a traditional sense as you'd think about in blockchains today. Proof of work in this case is used as a disincentive for people to spam the network with transactions. So when you create a send block on your account chain, you have to calculate, or your computer has to calculate, a proof of work value. And the difficulty moves up and down depending on volume of the network. And that proof of work value is basically your, skin in the game, so that you have to spend some time, spend some resources to send transactions on the blockchain so that you can't just freely spam the network. That's one of the things that people talk about when you think about free transactions on a blockchain or a DAG. How do you stop people from spamming? That's one way. You make people spend some resources to send a transaction so that they are incentivized to only send ones that they have to send. Overall, you look at this and you think, well, there are a lot of moving pieces here. There are a lot of things at play in this block lattice infrastructure, this ecosystem. But as a quick review, you essentially have all the different users, all the different accounts on the blockchain have their own blockchain. They have their own account chain. And from those account chains, if you want to create a transaction, you're going to create your own send block. And then on the other end, the directed acyclic graph, this block lattice, is going to be looking for a receiving block with the hash of your sending block. And that is your matched pair, your matched partner. And once that receiving block is signed, that transaction is set in stone. It is then immutable on both account chains, and there's a record of that on the directed acyclic graph, and the funds move accordingly. Now, that being said, of course, you're thinking about the state of the blockchain networks on both sides. You have one that is losing 50 nano tokens, for example, and one that is gaining 50. And then that is used as the basis for the next set of transactions that may occur for those account chains. Now, this is a very interesting way of doing it, using a directed acyclic graph to facilitate all the transactions that are going on so that you're not waiting for one stream of blocks to occur. You can have transactions occurring all over the place all at once. Now, this is faster, but there are obviously trade-offs that we talked about. There's no true consensus in this process. There's obviously protection against double spend. There's checking the inputs equal the outputs, etc. But there is no economic driver for consensus. Now, there are some ways that they can improve this whole process, and they've done so by adding proof of work as an anti-spam measure, adding proof of stake as a way to mitigate the risk of a frozen blockchain when people can't agree on how to move forward when there's an account chain fork. But that being said, how can we discuss economics when there isn't an economically driven consensus mechanism? I think that leads us directly into the token economics section of this video and how this cryptocurrency itself is formatted overall. Now, this is where it gets kind of interesting because I am traditionally not a big fan of cryptocurrencies like Nano. And there are things about Nano that I don't like. There are obviously things I do like the block lattice. I think it's a cool idea. But here's where I have some problems. Nano is a premine cryptocurrency, meaning at Genesis, when this network was first started, all of the coins, all the Nano cryptocurrency at the very beginning was already mined. Because there is no mining process, there's no proof of work to mine coins on a trickle-down basis. It is all sitting in a Genesis account or a Genesis wallet. And that means when people wanted to start using the platform, the owners or the founders of Nano had to send out or use a faucet to distribute the original amounts of coins. Now, in the Nano ecosystem, there is a pre-mined fixed supply of 133,248,290 tokens overall. Coins that were mined at the very genesis of the Ryblox or now Nano ecosystem. Now look, I'm not the biggest fan of pre-mines. I think pre-mines take away a lot of the economic drivers and a lot of the overall value that comes from the process of mining and continuing to slowly introduce supply, a fixed rate of inflation over time so that you can grow naturally with the demand for the cryptocurrency overall. That being said, the concern for me for Nano is really more of an economic one than a technological one. There's a lot of really clever stuff at play here. The implementation of using account blockchains to keep track of transactions in an immutable way, but to use directed acyclic graph technology to make things a lot faster and to allow for asynchronous transactions, I think that's a really, really good idea. I think that in the absence of consensus, because you have this block lattice structure overall, you're losing one of the core benefits, in my opinion, of a distributed, decentralized environment, and that is the ability to bring an economic-driven consensus mechanism. However, I think about this also. The economic driver for Nano could very well be that it is really, really fast and that it is dirt cheap, really free to use. So maybe, just maybe, that the whole entire idea that in a pre-mined cryptocurrency, the concept isn't for the Nano cryptocurrency as an individual measure of value to increase exponentially per token or per coin. The idea is that the whole entire value of the system, the entire value of the cryptocurrency is derived from the value of the service that the Nano platform provides. Another thing you may have read that you will say, hey, Nano's a scam, is about this whole BitGrail nonsense. Now, BitGrail was a really poorly run Italian cryptocurrency exchange, and the basic gist here is that Nano, that was one of the main places you could buy it. You could only really get Nano on BitGrail and a few other obscure exchanges, and Nano really pushed a lot of people to get cryptocurrency from there, just inherently because it was one of the places you could get it. Now, that being said, BitGrail ended up getting hacked, everything fell apart, lots and lots of cryptocurrency was stolen, including lots and lots of Nano. Now, that being said, a lot of people blame Nano and said, hey, this is your fault. You pushed a lot of people to do this. You coerced people to use this BitGrail exchange. Now, I think this is a really unfair criticism because the reality is that you as a consumer or me as a consumer, it's our responsibility to do the due diligence that's required to get that cryptocurrency in the first place. And beyond that, once you have the cryptocurrency you want, it's best practice to get it off of the exchange. Pull it off into your own wallet on your own computer at the very least. If not, pull it off to cold storage, to a hardware wallet if you can. Now, that being said, it isn't Nano's fault. It isn't the company's fault that everyone's resources were stolen just because an exchange where you could get Nano fell apart. Yes, should they have done more due diligence about the exchange that they were hosted on? 100%. Should they have been more upfront about the red flags if they saw them? 100%. Should BitGrail have been immediately found out as a terrible exchange? Definitely. There were red flags, and the reality is that in the future, I hope people will learn from the fact that you have to take your crypto off of exchanges. That isn't on the project, that is on the exchange, but it's also your responsibility as the consumer to do your own research and to pull your cryptocurrencies off of exchanges, especially ones that are super sketchy. And the only reason I even bring this up is because I think the BitGrail nonsense that happened really hurt Nano in the marketplace. It really hurt people's opinion of Nano overall as a project. And in this market right now, that really does make a difference. So I thought it was really worth addressing. And of course, you can come to expect this from every Hashoshi review, and that is to to talk about developer stuff. How is Nano doing on the developer front? First and foremost, there's no smart contracts or documentation therein because there aren't smart contracts. This platform wasn't built for that. It's a transaction network, not necessarily a dApp ecosystem. However, there are quite a few different libraries and different code snippets and pieces of documentation out there to help developers connect their applications to the Nano blockchain or block lattice ecosystem so they can create transactions and of course integrate it into their app. Now this is great. Anyone who wants adoption, they need to be doing this because the easier you make it for developers, again, to create applications with your platform, to connect applications that already exist with your platform, that's basically free volume. It's free use, free users, that's what you want. So obviously there are some things that I'd like changed. I would like them to definitely commit to these GitHub repositories and make sure all the branding is on point because there's a lot of references to Rye blocks and that stuff just hasn't gotten changed. That's probably because they're building the platform, not changing all the names in the GitHub repos. And I understand that, but in the future it makes it less confusing for people. And I also would love for them to have a sandbox environment where you can get test applications so you can see a full implementation in action using JavaScript, Python, some of the bigger languages out there that people are building applications with today. Now, as a testament to the fact that the documentation's there have been tons and tons of third-party wallet applications and odds and ends created on this Nano or what was once the Ryeblocks platform. So definitely people are building things and there's a community behind this project. So that is definitely a good sign. So overall, what are my thoughts on Nano? Now I know that this video I'm sure is going to get some hate from people who think that I was positive towards a pre-mined cryptocurrency, and then there's going to be hate about me being negative about the fact that it's pre-mined and that there are some concerns. I know people are going to hate it no matter what. That's just the way some of these things are. But I actually think that this integrated block lattice system, the amalgamation of blockchain at the user account level and then a DAG to connect all of these disparate pieces and keep track of state, I think it's a great idea. I think that all of these projects that are saying blockchain is the answer or DAG is the answer are being short-sighted. I think that there is a pitch, there's a use case for using these technologies in tandem with one another. And I think that is, in essence, something that people need to look into a little bit more. That's one of the main reasons I wanted to make this video, because I feel like DAGs and blockchains are set as rivals when they're actually very complementary technologies. And I think Nano is one of the few projects out there that has produced something, to me, in my experience, that really works as a use case or as an implementation example of that exact phenomenon, DAGs and blockchains working together. Nano also doesn't shy away from its identity. It doesn't say, hey, we're gonna be a smart contract platform tomorrow, and then after that, we're gonna be an e-commerce targeted platform, and then we're gonna be we'll do small transaction fees to pay people and all this other stuff, and then we're gonna change our minds later. They have a firm identity. They wanna be a fast, free, and scalable transaction network for e-commerce and global markets, etc. They have an identity, and that's not something all cryptos can say. I will obviously, again, reiterate, I'm not a fan of pre-mined cryptocurrencies. I think the economics behind a pre-mine without consensus is a dangerous game to play. However, I also understand that there are a lot of instances where the value of the product overall can really step in and take some of the heat off of the lack of consensus or economic consensus overall in the platform. So I'm not gonna write Nano off just because it's pre-mined. That's why I made this video, because there are some pre-mines that deserve a little bit of attention here. There are some pre-mines that have a use case, that have an idea that works. Nano, in my opinion, is one of them. I really wish Nano all the best of luck in building this platform out. It's gonna be a tough road economically to implement a solution that scales and has a lot of user base without a true consensus model and without some different transaction fees and things to keep people involved in this platform. I think Nano's doing all the right things in terms of mitigating the risks that there are in not having a consensus mechanism. They have 0 transaction fees, so instead they made it almost free and cheap as heck to run a node in general, so that you're not having miners or people doing all this work that costs a lot of money for no incentive whatsoever. Beyond that, they made the use case that the transactions are free and super fast, so people will use it even if the coin or the token itself is not worth a ton of money. So I don't think Nano should be compared one-to-one with platforms like Bitcoin, things like Ethereum, because they are so different that it's not even funny. I think this is kind of in a league of its own in terms of an implementation of this distributed technology, and we should treat it as such. Like any other project, they face problems, and their approach and their response to those problems have been pretty swift and pretty well done, so I give them kudos for that. And I think the main challenge they're gonna have is just generating adoption, getting people to use the platform, getting people to pay attention and to really jump on board and actively participate in the Nano ecosystem. I think that's a challenge that a lot of projects have, and they're no different. They keep pushing the envelope on their block lattice technology. They keep thinking of ways to mitigate the risk of not having a true consensus economic model. Then I don't see why Nano can't be successful in their own little niche in this cryptocurrency market. To be honest, I try not to write anyone off in this space because there's so many smart people at work here. There are a lot of people that get hate. There are a lot of people who get love. At the end of the day, the people who are heads down working to make this space a reality, make this space better, I'm in support, and I really hope that you will join me in that support. So guys, thanks so much for watching this video. Don't forget to watch more of my Token Talk Tuesday series. I'll link that on the screen here. I hope you have a fantastic rest of your week. Thank you very much. Cheers.